For National Electrical Code Section 450.3b, if the primary breaker is sized at less than 125% of the transformer rating, then primary protection is considered adequate. According to National Electrical Code Section 240.4f, protection of the secondary conductors is required when using a standard delta-wye transformer. This protection can be achieved by either using a main breaker in the panel board or using a separate secondary disconnect switch. A 120/208 volts panel board with a main breaker that meets the requirements of National Electrical Code Section 240.4f can provide secondary protection. The main breaker must have a rating not exceeding 125% of the secondary conductor ampacity. Alternatively, a separate secondary disconnect switch, such as a fuse switch or circuit breaker, can be installed near the transformer to provide secondary protection. It must be rated to interrupt the maximum possible secondary fault current. Let's explore two installation methods in detail, the first being a transformer installation with the main breaker in the panel board. Firstly, install the transformer securely on the floor. Secondly, connect the primary conductors from the 480 volts distribution board to the primary terminals of the transformer. Thirdly, install a 120/208 volts panel board next to the transformer and connect the secondary conductors to the panel board. Fourthly, install a main breaker in the panel board that meets the requirements of National Electrical Code Section 240.4f. The second installation method involves the transformer with a separate secondary disconnect switch. Firstly, install the transformer on the floor. Secondly, connect the primary conductors from the 480 volts distribution board to the primary terminals of the transformer. Thirdly, connect the secondary conductors to the terminals of a separate secondary disconnect switch located near the transformer. Fourthly, ensure that the secondary disconnect switch has a rating sufficient to interrupt the maximum possible secondary fault current. The location of the 480 volt source does not affect the protection requirements for the transformer and secondary conductors. In either installation method, it is highly recommended to label the disconnect device clearly as transformer secondary disconnect to clearly indicate its specific purpose. Now, let's delve deeper into the considerations for selecting the appropriate circuit protection for your transformer installation. Sizing the primary breaker involves understanding the transformer's kV amps rating and the primary voltage. Remember that according to National Electrical Code Section 450.3b, the primary breaker should ideally be sized at less than 125% of the transformer's primary current. For instance, if you are dealing with a 45 kV transformer connected to a 480 volt system, you would first calculate the primary current by dividing the kV rating by the primary voltage and adjusting for the square root of 3 for three-phase systems. This calculation would help you determine the appropriate breaker size, ensuring it doesn't exceed the 125% threshold stipulated by the National Electrical Code. When it comes to secondary protection, you have the option of using a main breaker in the panel board or a separate secondary disconnect switch. If you opt for a main breaker in the panel board, it's crucial to ensure that the breaker rating doesn't exceed 125% of the secondary conductor ampacity. This requirement stems from National Electrical Code Section 240.4f, which mandates protection of the secondary conductors when using a standard delta-wye transformer. Alternatively, you can choose to install a separate secondary disconnect switch near the transformer. This switch serves as an additional layer of protection and must be rated to interrupt the maximum possible secondary fault current. Determining the appropriate rating for the secondary disconnect switch involves calculating the transformer's secondary current and considering the potential fault current that could occur on the secondary side. When installing the transformer, pay close attention to the grounding requirements outlined in the National Electrical Code. Proper grounding is essential for ensuring the safety of the installation and preventing electrical hazards. Make sure to connect the transformer's grounding electrode conductor to the building's grounding electrode system in accordance with the National Electrical Code guidelines. Additionally, consider the ambient temperature and ventilation requirements for the transformer. Transformers generate heat during operation, so it's crucial to provide adequate ventilation to prevent overheating. Ensure that the transformer is installed in a well-ventilated area and that there are no obstructions blocking airflow around the transformer. Also, keep in mind the clearance requirements specified in the National Electrical Code for transformers. Maintain sufficient clearance around the transformer to allow for safe access and maintenance. This clearance should be free from any obstructions that could impede access to the transformer or hinder its operation. When connecting the primary and secondary conductors to the transformer, use appropriately sized conductors and terminations. Refer to the National Electrical Code tables for conductor ampacity to determine the correct conductor size based on the transformer's current rating. Use listed and labeled terminations that are suitable for the type and size of conductors being used. Make sure to tighten all connections securely to prevent loose connections, which can lead to overheating and potential electrical hazards. Consider the overcurrent protection requirements for the primary and secondary conductors. Install overcurrent protection devices, such as fuses or circuit breakers, to protect the conductors from overloads and short circuits. These overcurrent protection devices should be sized in accordance with the National Electrical Code guidelines and should be readily accessible for maintenance and testing. When selecting the location for the transformer and panel board, consider factors such as accessibility, environmental conditions, and proximity to the load. Choose a location that is easily accessible for maintenance and testing and that is protected from environmental factors such as moisture and extreme temperatures. Locate the transformer and panel board as close as possible to the load to minimize voltage drop and improve overall system efficiency. Be mindful of the labeling requirements for the transformer and panel board. Label the transformer with its kV amps rating, primary and secondary voltages, and other relevant information. Label the panel board with its voltage rating, ampacity, and the location of the circuits it serves. Clear and accurate labeling is essential for ensuring the safety and efficiency of the electrical system. Follow all applicable codes and standards when installing the transformer and panel board. The National Electrical Code provides comprehensive guidelines for electrical installations, and it's important to adhere to these guidelines to ensure the safety and compliance of the installation. Consult with a qualified electrician or electrical engineer if you have any questions or concerns about the installation process. Regular inspections and maintenance are essential for ensuring the continued safe and reliable operation of the transformer and panel board. Conduct periodic inspections to check for any signs of damage, wear, or overheating. Perform routine maintenance tasks such as tightening connections, cleaning components, and testing overcurrent protection devices. Keep accurate records of all inspections and maintenance activities to track the performance of the equipment over time. In summary, installing a transformer and panel board requires careful planning and attention to detail. By following the guidelines outlined in the National Electrical Code and adhering to industry best practices, you can ensure a safe, reliable, and efficient electrical system. Remember to prioritize safety at all times and to consult with qualified professionals if you have any doubts or concerns.